Other than our Earth, there are 7 other planets in the solar system we call home. There is Mercury, the closest to our Sun. Venus, Earth's closest neighbor. The red planet Mars, that is thought to have once had running liquid oceans of its own. The gas giant Jupiter, Saturn the ringed planet. Uranus, and finally Neptune. If you decide to include the dwarf planet Pluto, the furthest planet from our Sun, a total of 8 planets, lives silently. For years, we have wondered, what if another planet, in another solar system, light years away, could also harbor intelligent life? But what if it were possible, that not just one solitary planet, not 2, but many worlds orbited one star, within the habitable zone? Something astronomers have been speculating about, since the discovery of TRAPPIST-1, located 39.6 light-years from the Sun, in the constellation Aquarius, which hosts 7 Earth-sized, temperate exoplanets, orbiting an ultra-cool, dwarf star. 3 of them, TRAPPIST-1e, F, and G, dwell in their star's so-called habitable zone, or Goldilocks zone, a band around every star, where astronomers have calculated that the temperatures are just right, not too hot, nor too cold for liquid water to pool on the surface of an Earth-like world. But just how many Earth-like worlds could one system contain within its habitable zone? Although the data suggests more systems such as TRAPPIST-1 could exist, scientists haven't spotted many stars that seem to have multiple planets within their habitable zones. This question, among many, stimulated the mind of one astrobiologist, Stephen Kane, from UC Riverside, who asked that very question. Kane, who led the study published in the Astronomical Journal this week, said, "This made me wonder about the maximum number of habitable planets it's possible for a star to have, and why our star only has one. It didn't seem fair." These questions prompted a new study by Kane looking at the relatively nearby planetary system. To understand how many habitable planets a solar system might be able to support, researchers created a model that allowed them to simulate planets of different sizes, orbiting different stars. It accounted for the way that those planets would interact with each other, as well as how they orbited around their host star, stretching over a theoretical time of millions of years. A study that led Kane's team to answer that very question. Kane's study concluded that a star like our own Sun, a Type G main sequence star, could support up to as many as 6 habitable planets within its Goldilocks zone, with the possibility of other kinds of stars supporting a full 7. Each of them with liquid water and the right conditions for life as we know it to emerge. More than that, and the planets would move too close to each other, disturbing their orbits. The research also helped better illuminate the reason our system has just a mere one habitable planet, and the conditions that could change that. Kane said, "By measuring the properties of exoplanets, whose evolutionary pathways may be similar to our own, we gain a preview into the past and future of this planet, and what we must do to maintain its habitability." Projects like these offer more than just new avenues into the search for extraterrestrial life in outer space, and answering the question, are we alone in this vast universe? But they also offer scientists understanding into what forces might change life as we know it on our own planet one day. Although we know Earth has been habitable for most of its history, many questions remain regarding how these favorable conditions developed over the last 4.5 billion years it's been in existence. And the specific driving forces behind those changes that reshaped our planet into what we see today. A planet booming in life. So tell me, are you wondering about the mysteries of the universe? Or even mysteries closer to home? UFO sightings, our own lost civilizations, or even what is beyond life? For that and more interstellar happenings, click that subscribe button now.
Mystery.